Now, another common form of a line equation is the following. See the following. Y minus 3 equals to 1/2 x plus 1. Now, this is what we call the point slope form of a line. So let me show you the generic form of this. It's like y minus y1 equals to m times x minus x1. Okay. I'm going to explain what the x1 and y1 means later. Okay. But just compare this with that and see that y1 must be 3. And since negative x1 is 1, that means x1 must be negative 1. Okay. For now, just compare them and see that y1 is 3, m is 1/2, and x1 is negative 1. Okay. Now, without actually trying to figure out what x1, y1, and m are, let's just start again from this one and see if we can draw the graph. Now, what made us successful in the previous methods was that we were able to identify some points, and then after that, we just use the slope, because that tells us how much x to increase and how much y to increase, right? So here's a nice approach to this. Just think about, okay, so think. What will make both sides equal to 0? Now, why would I think that? Well, you're going to see later. Okay, just for now, let's just think. Okay, so for y minus 3 to be equal to 0, you need y to be what? 3, because 3 minus 3 is 0. Okay, so we know that y goes to 3 will make it 0. How about this side? For what value of x would this become 0? When is x plus 1 equal to 0?
Negative 1.
Negative 1. Negative 1 plus 1 is 0, right? So you know that x is negative. Okay. So, here is what we understand. If we plug in negative 1 comma 3 into this equation, this is what we get. We get 3 goes into y, right? 3 minus 3 equals to 1/2. Negative 1 plus 1 equal to 0. Negative 1 plus 1. Okay. Now, let's ask. Does this point, negative 1 comma 3, lie on this equation? Lie on the graph of this equation? Let me repeat my question. Does this point, negative 1 comma 3, lie on the graph of y minus 3 equals to 1/2 x plus 1?
Yes.
Why do you think so?
That's how the equation is.
Because when we plugged in, what happened? The left side became 0. The right side became 0. Is 0 equal to 0?
Yes.
Of course it is, right? So when you plug in negative 1 comma 3, the equation does work. Okay? Whenever this equality holds, if the left side and right side evaluate to the same number, then we know that point is on the graph, right? So we do know that negative 1 comma 3 is on the graph. Okay, that's a good knowledge. Next, another thing that you should look from here is trying to multiply this out, and it kind of gets ugly, but bear with me. 1/2 x plus 1/2. 1/2 times 1 is 1/2. And then add 3 both sides. And you get y equals to 1/2 x plus, what's 3 plus 1/2? I don't even know. So I do know, but I'm just saying. Okay. So you put this into the slope intercept form, right? What is a slope intercept form? It's y equals to mx plus b. That's slope intercept form. And we found out that the slope is what? What's the slope? 1/2. It's right there. Okay. So what I want you to think about is the following. Don't worry about how I got here or even this number. We don't really care. What I care is that if you were to change this by solving for y, and we did all the algebra, at the end of the day, this number will end up where? Exactly right here where the slope is. Agreed? Okay. So, we go back. And let's write down the two important observations that we made. Observation number 1. Negative 1, 3 is on the graph. Observation number 2. 1/2 is the slope. Okay, then we can draw this. How? Negative 1, 3. Oh, I should make this. Let me make this. Okay. Negative 1, 1, 2, 3. Here's negative 1, 3. And then the slope is 1/2. That means when you have change of x as 2, then change of y should be 1. So you change x by 2, 2 steps, and change of y should be 1 step. What's this coordinate? This is 1, and then this will be, this was 3, so this is 4, so this is 1, 4, right? So that's the next point. And then go 2 steps, 1, 2, 3, so you're at 3, and then you go up by 1, so you're at 5. And connect these. That's the graph. Okay? All right. Now let's go back to the following equation in general. So what's at play in general? This equation, which we call the point slope form, has two facts. Fact number 1. If you replace x by x1 and y by y1, just like how we replace x by negative 1 and y by positive 3, so that this becomes 0, this becomes 0, what happens if I replace x by x1? What's x1 minus x1? I don't know what the value of x1 is, but I know what x1 minus x1 is. That'll be 0, right? What about y1 minus y1?
0.
So does this equation become satisfied when I plug in x1, y1?
Yeah, because
They're both 0. So we know that x1, y1 is on the graph. Very clear, right? Yeah. Becomes 0, 0, right? Number 2, what's the slope? Huh? M. This m. The number 1/2 like here, that slope will be m. So slope is m. And that is actually the important thing I wanted to show you. So look. Here's a question, another question. Find the equation of line passing 1, 2 and has slope 3. We can quickly get the equation by using the point slope form. Let's try it. So it passes through 1, 2. So where does 1 go? Right here. Where does 2 go? 2 is y1. Where's y1? Right here. Okay? And what's the slope? Slope is 3. Where does 3 go in? Into m, right here. Okay? So let's write down the equation. You get y minus 2 equals to 3 x minus 1. That's the equation. Now, let's just solve this for y to change that into slope-intercept form. So this is 3x minus 3. Add 2 both sides, and you get y equals to 3x minus 1. Now, compare this with any other method. This is pretty good. Okay? I mean, there are other ways to do this question, but I really want you to learn this, especially because most of you are trying to get into the next class, which is Calculus 1. In Calculus 1, this method, this point-slope form actually becomes more important than the slope-intercept form. Okay? This is what we call the point-slope form. This is what we call the slope-intercept form. In calculus, this becomes more important. Okay? That's why I want you to learn this.